G'day guys. I recently got an alcohol breath tester from work. It's a QM7298 catalogue number. Basically I decided to open it up and realised it had an atmel48V MCU in it, and conveniently had the header pin out for the in-system programming as well. So I hotwired her up and got the power through to it and decided to have a go at programming it. So I got my Arduino out and programmed it up as a in-system programmer. Saved me a couple hundred in an AVR programmer, and hooked it all up and played around for a bit, and eventually got it all to work. And so I've got it all working beautifully with the Arduino IDE, and so I loaded up a couple of sketches. This one's I loaded up the tone library and just had a Mission Impossible theme running, and so I hooked that up now. And I also just did a blink sketch and just soldered an LED on to the same place where the speaker is now on that board. And yeah, so you can write your code in Arduino IDE, and you can also upload it via the Arduino IDE as well. You don't have to go to AVR dude to do that. Though to start off with, I did go to AVR dude because I had to set some fuse bits to set it to use the internal clock, but at 8 megahertz, because by default it's actually set to use it at 1 megahertz. So bump that back up so that everything runs properly, and yeah, wonderful. So I'll get into a bit more about how it was programmed and what I did there to get everything up and running. But the same principle applies for any atmel chip that you come across. And yeah, just pointing out here that there's a few more. There's about 10 pinouts on the back for general import output. It's about 30 grams in size. The 30 grams. So it's about 3 grams in weight. The chip with the speaker on board, so it's quite lightweight, which is what I was looking for. So now I'll get on to how I programmed it. Okay, so the first step in trying to get this little board to have some code uploaded to it was of course figuring out the pinout. Now on the bottom of the board there was just these 6 holes, which I got the multimeter out and continuity and sort of found, and the data sheet of course for the atmega48, and found that there was ground voltage on either side, and this went to the reset pin, and there were all the other corresponding pins. And from there I had to of course make the Arduino an in-system programmer, which effectively any uploads that I chuck at the board, they're going to want to throw back out to another board. Essentially that's the easiest way for people who don't really understand what in-system programming with the Arduino is. You can access that via the examples Arduino ISP. So the board I was running on to upload all my code was this is a board here. So I chose that and uploaded it to my board, and then for Arduino IDE to know how to compile my code for my board, I needed to make a little hack in the boards.txt file, which is under the hardware Arduino folder in your Arduino install. So at the bottom here's my AT45. Oop. Just noticed a little mistake there. That's what I needed to add. It's just got all the fuse bits, the speed of the upload, the maximum size of the sketch that can be uploaded to the board, and the name of the board itself. And so now when I compile my code over here, I pick Rotec QM7298, and now when I verify that, it actually compiles it ready for the 48 chip. From there, to avoid going over to command prompt and AVR dude, which you can do, it isn't terribly hard, but just to avoid it and make it a bit more noob friendly, I found that I could go to programmer, and normally you set to AVR ISP MK2. That's like usually what it's set to when you're just uploading sketches to the board itself. But when you're using your Arduino as an ISP, you go Arduino as ISP, and then that way any code that I chuck at it, it's gonna redirect to the to my board via these pins. So, and that's how I did it, and away she goes. I'll leave you with a couple of pics of pinouts and whatnot, and yeah, catch you next time. If you have any questions, hit us up on YouTube or whatever. Yeah.